It's time to move on to our second type of hypothesis test. This time we're going to do a test for a mean. So we're going to be testing hypotheses regarding a population mean mu. And if that's the case, notice right here I have in this the t-test. That'll be the test that you'll use on your calculator to help yourself. And just to be clear, this is in your inferential statistics info packet that you get to use on your exams, the neon green portion of your course pack. So you have, this is the t-test, then you have these requirements. These are the things that have to be in place in order to conduct this test. You can also call those assumptions. They're the assumptions we have to make in order to do a test. So I could put AKA assumptions. So these are the things that we assume to be true. And if we can't assume them, then we will prove them true. So the first thing you need to have is a simple random sample, of course, because we can never do anything without a simple random sample in this course. Then you have to have that the sample has no outliers and comes from a population that is normally distributed, or n can be greater than 30, right? So you can either have no outliers, normally distributed, or n is greater than 30 to ensure that the distribution is normal. You need normality to do this. And then you also need that little n, your sample size, must be less than 5% of capital N, which is your population size. And that part is to, again, ensure independence of your samples. Then you'll state your null and alternative hypotheses, which should look very similar to what you were doing in the last section, except now your parameter is mu, not p. So we're interested in the mean, not the proportions. You'll have your alpha, which is your level of significance. Then you'll have your test statistic, T0 now, because we're no longer working with the Z curve. The Z curve is for proportions, just like with confidence intervals. And then the T curve is what we use for running the tests. So it's T0, which is x bar minus mu 0. The 0 is from the null hypothesis, the zero hypothesis, if you will, over S over the square root of n. And then you have to choose if you're using either the classical approach or the p-value approach. Your steps 4 and 5 will be different for the two methods. And then you will compare your critical values with the test statistics and so on. If you're doing the classical method, or if you're using the p-value method, you'll go, is the p-value less than alpha? And then we will state the conclusion. All right, so according to the US Mint, quarters weigh 5.72 grams. A researcher is interested in determining whether the new state quarters have a weight that is different than the old value of 5.72 grams. Technically, I know grams is not a measure of weight, it's a measurement of mass, but bear with me here. All right, so he randomly selects 18 state quarters, quote unquote, and weighs them and obtains the following data. So there we have these lovely 18 quarters and their mass in grams. So are each of the requirements for a hypothesis test satisfied? Explain. All right, so let me type up the requirements. I'll be right back. All right, there they are. So the first requirement is that we have a simple random sample. So do we have that? And the answer is yes, because it states right here that they're randomly chosen, right? So this is a random setup, random sample, right? Given in the problem setup that it was random, right there, that word random. Then we need to know that it's normal with no outliers or n greater than 30. Well, n is not greater than 30 for us. That is not happening. So we need to prove that it is normal with no outliers. So we need to prove the data set is from a normal distribution with no outliers. The graphs at right or at left, sorry, I don't know my left or my right. The graphs at left show the data set. Here, let me type this. 1 second. There we go. That'll be easier. So we need to prove the data set is from a normal distribution. That's what the top graph at left shows, with no outliers. And that's what the bottom graph shows. Top left graph shows. And then no outliers, that's what the bottom graph shows. Bottom graph being a box plot that we've seen from chapter 3. It's been a while. All right, so now, then we need to know, is n less than or equal to 0.05 capital N? Well, this is going to be a little bit of a hand-wavy argument, but yes, because of course 18 whatever this 18 quarters is far less than 5%. 18 quarters is far, far less than 5% of all the state quarters that were minted. I mean, they minted thousands, if not actually millions. So if that's the case, then 18 quarters is far, far less than 5% of that. 5% being, of course, 0.05. All right, so we have our assumptions met, our requirements met. So now we can actually conduct the test, and that's what we're going to do.